Hey guys, it's IDW, and today we are going to be talking about machine code syntax. Now, before we get into things, I want to briefly talk about skipping videos in this series, because in the last episode I made it pretty clear that the stuff that I'm going to be doing in this series is going to be very much beginner friendly. So there's going to be a lot of things, including this episode, that you might already know if you've watched videos on my channel or just know a bit about background in general. So that said, in this video we're going to be going over machine code syntax, which is basically how you make a binary number into an instruction that a CPU will interpret and do something with. So, if you've seen my Building a Redstone Computer series or know what that is, then it's okay with skipping this video. In general, I'm probably going to explain to you before the video starts, like who exactly should probably skip the video and who should not. So, yeah. So with that out of the way, let's get into these things, and let's start talking about the data loop. So, what is a data loop? Well, in a computer, we have information, and it's stored in these things called registers. A register is your most basic form of memory. It's something that's really fast, and it's just the first thing you probably want to store stuff in. So the problem is, cool, we've got this information stored in the registers, but let's say that we want to edit it. Well, we go through a process of taking the information out of the registers, manipulating that information, and then we can just send it back in. And you might send it through an adder or an ALU in general, but we're not talking about that in this series. But this general process is known as a data loop. Why is this significant? Well, it has everything to do with machine code syntax, because all of machine code syntax is based around this data loop. What I mean by this is that each instruction is going to be representing one data loop, so one state where information gets read out of the registers, gets manipulated, and gets saved back in to the registers. And each instruction is going to represent this. So what we're going to do is we're going to have different parts of our binary arrangement represent different parts of this data loop. So for example, we're going to have a source from which the information is going to come, something that's going to tell us how we're going to manipulate the data. And finally, we're going to have something that is going to have our destination register. So we're going to have one bit of information that's going to say where it comes from, one bit of information that says what we're doing with it, and one bit of information that tells us where we're going to do. And that's mostly everything, honestly. It's very, very, very simple. And there's actually a few exceptions from stuff, but one important thing to note here is that the specific syntax actually varies from computer to computer. For example, the computer that I'm using probably has the different individual bits arranged somewhat differently than what I have. Because what you're going to do is you'll have a whole bunch of wires, and different parts of those wires are going to represent different binary numbers that represent like your source and your destination. And that's going to vary from computer to computer. Moreover, CPU to CPU, but we're not talking about that now. So, other parts of syntax. Now, while defining parts of the data loop is basically what's going to be going on for most of the instructions, there's a few simple exceptions. The first one we're going to talk about is a mode. Now, a mode is a bit that is basically going to tell us if we want something other than the information that we already have in the register. Now, even though we have registers and they're really fast, there's a limited amount of space in them. So what we're going to do with the mode is we're basically going to say what we're going to take from the register is just going to be an address that we're just going to plug into memory, and we're going to use that instead of the register. So that's really all a mode is. It's just a single bit that's going to tell you that. There's more complicated stuff as you get into like more advanced levels of this, but that's basically what a mode is. And then here's the really important one, branching. Modes are really important too. We're going to talk about them later in the memory hierarchy, but branching is probably the most important part for this series specifically, because it's going to allow us to do all of these higher level coding things that we wouldn't be able to do with our lower level machine code. And branching allows all of these things to happen. So what a branch is it's basically, most of the time you're going to want to go through your instructions in a specific order. And you're going to have like a huge list of all the instructions you're going to do, stored somewhere, probably in memory. And what you're going to do is sometimes you don't want to go through them in a specific order, like do this one, then move on to this one, then this one, then this, etc., etc., etc. So what a branch is it's basically when you're going to go out of your way. Now you might think, well, that's not much help. Just because we go out of our way, it doesn't necessarily mean that it's going to take advantage of something. Like, why don't I just put the line of code that I'm branching to as my next line? And the reason that it's so significant is that we're going to use something called a Boolean, which is a true-false statement to determine whether or not we're going to go to this address, or if we're just going to keep going through our code like normal. And this is the basis of just so many different parts of code. For example, if-then-else statements, you've probably heard of those. Those are really just a simple branch. Loops are made with branching, and branching unconditionally is what you do when you do a function. And all of these things, you have to actually put them into your code, and there's like no default thing when you're going through machine code. And this is why it's just such an important part of what we're talking about now. And that was really everything. Again, very simple stuff. So yeah, I hope you guys have enjoyed, and I will see you guys next time.